This is our discussion of forages and grazing for the livestock class. There are several very important families of forages to know when you're looking at animal grazing, and we have already discussed some of the plant families, including grasses, legumes, and brassicas. Grasses include orchard grass, tall fescue, which you've seen at the farm. Other important cool season forages to be aware of include Timothy grass. Bermuda is actually a warm season grass, and we have some at the farm, but we haven't been discussing it as much since it's warm season. Important legumes or nitrogen fixers include clover, red clover, and white clover, which you've seen at the farm. Alfalfa, which is in the high country, but we don't have as much of it at the farm. These are important legumes and grasses to know, the 7 that I've mentioned, and you actually have more information about these in your Forage ID assignment to learn how to identify these forages. Other important forage families include the brassicas, which is actually the cabbage family. You might be more familiar with this in terms of crop production or cover crops. But turnips is an example of a forage crop that's often planted for cattle to eat the leaves, to eat the forage. Other families are generally grouped in a description called forbs, and these can include many other plant families, often weeds that may have quite a bit of nutrients for grazing animals such as cattle. Dandelion, plantain, you've probably seen these at the farm. In the U.S., it's important to be aware of where our native rangelands and grasslands are, and also what is introduced pasture. East of the Mississippi, these are all and almost entirely introduced forages, cool season, warm season, and mixed forages, such as tall fescue. But west of the Mississippi, we do have a lot of intermountain rangeland. We also have very high-quality grasslands in the U.S., like some of the major grasslands across the world, in Australia, in South America, in the Pampas area. Our grasslands include the Great Plains prairie, and it does include tallgrass prairie and also shortgrass prairie, as well as mixed type prairie grasses, either northern or more southern mixed grass prairie, including Palouse prairie, and also some of the semi-arid or desert type rangelands. It's important to be aware of different growth types of forages. If we look specifically at legumes or nitrogen fixers, we can consider clovers. The white clover does tend to be, doesn't grow as high. It's a shorter type forage on pasture. And I think here on this axis it gives you an idea of the heights. White clover and ladino white clover, which is a larger type clover leaf, they do grow lower than red clover or alfalfa. And they spread mainly by stolons. You can learn more about forage morphology by looking at your Forage ID assignment. And you'll see how the stolon is a rooting stem, and that's how this type of clover grows. Red clover is a hairier type of clover. You can recognize clovers often by the 3 leaflets and the white watermark that's on them. Alfalfa has a taller growing pattern than most of the clovers, and it's also stemmier. It's also important to be aware of the growth types of grasses. And you can see from this diagram that orchard grass and tall fescue definitely tend to be some of the taller grass forages on pasture. Bluegrass is much shorter. An important distinction between orchard grass and tall fescue and bluegrass is that these two they grow in a bunch grass pattern, but bluegrass grows more like a lawn, actually a sod grass. And you can see the rhizomes here, that this is how it sends out new tillers. Bermuda grass, this is a warm season grass, and it also grows as a sod grass like Bermuda does, or I'm sorry, like bluegrass, and it tends to make more of a sod or lawn. If you're trying to do year-round grazing, it's important to know when these different types of forages grow. Kentucky bluegrass, orchard grass, tall fescue, you can see that these are cool season grasses, and they have two peaks when they grow most abundantly: in the spring around May, and at the end of September, early October. About this time of year, it's the second peak. So for all of these, which are cool season forages, you can see that type of growth pattern. They don't produce as well during the hot summer months, and that's when you do need your warm season forages like Bermuda grass. We do have switchgrass. We also have a foxtail meadow grass. It's not listed here, but that's one that we see a lot at the farm. And warm season grasses, they have their peak of growth during the summertime. Small grains such as ryegrass or oats, barley, they can also be planted to extend the growing season on either side of the cool season periods. So you can start to see here on this diagram how you can actually have year-round grazing. Although January, December and January are times where there's no active growth, and that's when you can stockpile forage. You can actually stockpile your forage instead of haying it. You can leave it in the field to give you year-round grazing. The different grazing systems that are commonly used include continuous grazing, which you've seen. It is the type of grazing system that requires the least amount of labor and effort. But if you're willing to add infrastructure such as fences, watering systems, and use labor, there are many benefits to rotational grazing. And this image does show cattle being rotated through 4 paddocks. Another way to move cattle on pasture is strip grazing. We haven't discussed this type as much, but we have actually used this at the farm at times. Strip grazing moves cattle in one direction. It doesn't actually rotate them. Strip grazing is very useful, for example, for the stockpile forage when you graze it in the wintertime, that once you graze it, it's gone, and so you're not waiting for it to come back in 30 days. It won't actually come back until spring regrowth. But it's a way to use your forage, have the cattle on this paddock, and move them to this one so they don't trample it. And often there's no need to back fence with strip grazing. If we compare the different types of grazing, continuous and rotational, I think you're aware that in continuous grazing, the desirable plants are regrazed before they actually have the opportunity to recover, and therefore they tend to die out, and undesirable plants grow and seed and take over your pasture. However, rotational grazing allows these desirable plants, such as clover or high-quality orchard grass, to rest and recover from grazing. So the result is a higher quality pasture with more diversity. The need for supplements and harvested forage or hay declines, and it also reduces weeds. This image shows how continuous grazing, when you have a continuous period and no recovery is allowed, that the root system of the forages will diminish and the forage will not be as vigorous and will actually die out over time. After grazing, the plant depends on its roots for reserves to be able to put on regrowth. If you have a short grazing period with a long recovery, as what takes place in rotational grazing, then the plant depends on its root reserves and it has a rapid regrowth and continues putting energy to its roots. Other grazing systems may fall in the middle, but you can see the impact here of giving the forages a rest. Rotational grazing systems are actually based on nature. In nature, herds of grazing ruminants, bison, antelope, sheep, they bunch together because they've been harassed by predators. They've been harassed by wolves, grizzlies. In Africa it might be lions. There's many predators that follow the herds, and so they bunch together for safety. And that does give them a heavy impact in one area, but then they move on and the area is allowed to recover. Humans have been herding animals for a long time, and this is generally how they do it. They don't use electric fences, or they didn't in the past. They used herdspeople. But now we use electric fences to bunch our grazing ruminants together and have this same impact that we have seen over time in nature. Rotational grazing in the U.S. was popularized by Holistic Management International. When looking at different grazing systems, it's important to determine when to graze or harvest the forage. And you've actually already seen a similar type diagram earlier in the semester in our feed PowerPoint. You saw, we looked mainly at grasses in that diagram, and you did see how over time with growth, dry matter is going to increase. For that matter, so does fiber and lignin. And over time, and this axis does show plants growing in dry matter. It also shows over time. The y-axis shows the nutrient composition. Over time, protein and some of the soluble carbohydrates will decrease. In this diagram, you can see the growth stages for not just grasses, which you've seen before, which showed the vegetative phase, the boot stage, before the seed head emerges, the heading stage, which with a grass is when the seed head actually emerges, and then the bloom stage is when you have a ripe seed, or in some cases a ripe grain. It's similar for legumes. We've looked at it already with grasses, but with legumes, this stage here is the leafy stage, vegetative. And then we do have a pre-bud stage before the flower emerges. Here the bud emerges, and this is the bloom stage when we have flowering. In both cases, with grasses and legumes, the ideal time to graze or harvest is here in the middle of this X. It's the time when we do have dry matter, when there's been some growth, we have some volume on these forages, but it's before the quality decreases too much. So this is the stage. It's actually a boot stage, early to mid boot stage, before heading or bud. And this diagram gives, I think, an even better image of a growing season or regrowth after grazing, when you would graze again or harvest the forage. So again, on the y-axis, you do see a total pasture dry matter, pounds per acre. And you can see that the ideal time is in this phase 1 to graze. because dry matter is increasing. There is more forage to graze. However, lignin and cellulose is also increasing. And the X here indicates the time where protein and palatability is going down, but this is the ideal time. I think it can help to take a closer look at forage development to understand this. The vegetative, this is a time when the tillers are producing leaves, and this is with grasses. The stem elongation is when the nodes begin to emerge and elongate in the stem. The boot stage, and this is the ideal time for grazing before the seed head actually emerges. The boot stage is when the seed head is still in the sheath of the flag leaf, the leading leaf, and it's just beginning to come out. Heading is when the seed head actually comes out. This is the ideal time for making hay, because this is better for grazing, but when it starts developing, if it gets past you and you haven't managed to graze yet, this is the time that you would make hay. But the anthesis, when the seed head has emerged and the flower is starting to shed pollen or develop into a mature seed, this is beyond the ideal stage, and this is when you have much more cellulose and actually more impact on methane in the atmosphere because of the amount of cellulose. I'm hoping that you can see that even better with these pictures here. With the stem elongation, you can see jointing jointing begins with an elongation between the nodes. Here in the early boot, you can actually feel the seed head in the sheath of the flag leaf. This is what it looks like, and you can actually feel that before it begins to head out. Rotational grazing does require some investment. It requires investment of fencing and water facilities, and it also does require labor. Perimeter fence is generally a high tensile electric strand, and this is generally going to be permanent fencing that you tighten these fences. Here's a wood post being used, but you can also use metal post. I think a wood post is being used here because it makes an anchor post, a stronger one. This is high tensile electric strands that are generally, you keep about 4,000 volts on this to be able to deter cattle from breaking through. But then you also cross fence with temporary step-in posts. These are step-in, and generally a electric polywire or poly tape. And it's not a high tensile, it's one that's, y'all have seen how we string it. It's pretty easy to put up. And it does take time to move the cattle, but it may not take as much time as you think. This was a producer, actually a colleague I used to work with in Arkansas. I visited several years ago at Ozark Pastured Beef, and Dr. Morrow here is just lifting up. He's making an instant gate. He just lifted up the step-in post for the cattle to be able to walk underneath. And he moved about 100 cattle in 5 or 10 minutes. He just lifted this post and the cattle were ready to move to this paddock. You can see they have more forage here to graze. Some of the design examples for paddocks, I've included the North Pasture paddocks at the SD farm, and you've seen how our North Pasture is set up, that we just move from paddock to paddock when we do rotational grazing. This is the right side of the pasture that you've seen more heavily used. And we have some guidelines that tell us where we can make our paddocks to make them all almost 1 acre, but we can make these paddocks as big or small as we need to with front fencing and back fencing. And this line here actually shows the 4 T-posts with blue on them, which indicate the hydrants in the field. So our water tank is portable. We can move it from paddock to paddock. And our mineral feeder is also portable. And we've had shade structures that we also move from paddock to paddock. Another way to do that might be with a central lane. We could set up a central lane and even a corral, and this is another way for cattle to access different paddocks and generally not have to move water. You can have a permanent water source and they can just walk in here to get water. A wagon wheel is another type of design that I think you've actually heard Eddie discuss as one of his favorites. In this case, you can have a centrally located water or mineral feeder and let the cattle into the central area and then back out to their paddock. So you can have permanent installations of waterers. It's important to think about how to feed cattle or other ruminants in the wintertime when the forage is not actively growing. So in this case, we usually do harvest forage for winter in the form of hay, if it's dry, or if you have wet periods when it's time to make hay, that's a good time to make silage because hay needs to dry. It needs to be cut. It has to have the chance to dry, usually for almost a week, and then you gather and bale it and store it. You can make these large bales. Some of them are pre-wrapped to protect them from the weather, or you can cover them with a tarp. And then of course you need to feed the hay, so you need to have a ring or a method for feeding hay in the pasture in the wintertime. There's many ways to make hay, and I'm hoping that we'll have the opportunity to see the machinery that's needed to mow and then flip the hay over and then gather it for baling. Or you can do it with a scythe, and this of course is a very old tool. Some people are very fast with scythes, and you can see in this image, this is several people cutting hay in a hayfield with scythes by hand. You're not going to have a baler in this case, so you don't have machinery. You still do have to flip and dry the hay so it can dry out, but you would in this case have to make a haystack. And generally you want to protect your hay. Some of the old-fashioned haystacks would roll moisture right off, but when people make haystacks now, they usually put a tarp on. Another alternative to haying is stockpiling, and this actually reduces the need to harvest forage. In our part of the country, the way you stockpile is in mid-August you stop grazing or cutting, or you do your final cut in mid-August, and then you don't cut again. You allow the forage to grow throughout the fall and stockpile for the winter, and then you strip graze it in the wintertime. And that's what this image shows, is cattle grazing on stockpiled forage. I think it's a very interesting alternative because it reduces the amount of machinery and labor that's needed because the cattle actually just self-harvest. This is the end of our discussion.